So hi, Sean. Welcome back. The last time you were here was in March.
Okay, March. I was wondering when it was because we talked about getting back together again for an update on GraalVM progress.
Exactly.
So I think that, I was looking over some of the topics because I was thinking, how far back do I need to go on updates? So March, okay.
Yeah, and this date today was set in March because you said, the release train is very precise in GraalVM. So if we meet there, there's a lot features to cover. So I hope it worked out for you.
Yes. I mean, we have no choice in the sense that we're a JDK release, so there are CPU release dates, right, which have to go out on a certain date. So we're locked in. So really, I mean, from a release perspective, those dates can't move, right? The most you can do is say, well, a feature can't ship. You can't, slip the release date. It's not going to happen.
So GraalVM ships together with JDK?
Same dates. Yeah, same dates. So openJDK ships. Actually, we're a bit behind. There's some timing issues. So the Enterprise Edition, the Oracle comes from. We get Oracle JDK and build on that. So we have internal access to their builds, of course, and we can put out the CPUs same date. OpenJDK, we have a few days delay there, just to make sure we have them.
Okay.
So it is what it is. But basically, we're on the same train, right? So even with a couple of days here and there, we're on the same train for Community Edition.
So, but you are not supporting Java 17 yet, right?
Yes, 17 support. That's one of the big features we rolled out. Yeah.
Okay.
Yeah, so we were 6 weeks. So Oracle JDK shipped 17 in September, and then we shipped 17 support in our next release, October. So we're on time. Yeah, for sure. 17 support across the board. Native image has 17 support. JIT compiler stuff is supported in 17. So that was a big feature.
Yeah.
Although I think going from 11 to 17 wasn't a huge change as compared to 8.
Yeah.
But it turns out that I think some of the complication is because Loom is making lots of interesting changes under the covers to the JVM, which the average developer isn't seeing, right? So these are future-facing changes that are, at some point when Loom ships, the JVM has to be ready. And so there's changes going on, and for us, that has a big impact on native image.
Yeah.
Where we're having to basically keep up with those changes, right? So there's quite a bit of engineering work just to keep up with what's going on inside the JVM. Again, below most people's notice, they don't see it.
Mm-hmm. But what I'm the most excited with in Java 17 are text blocks, because it helps me a lot with JSON, actually. And
Yeah, text blocks, for sure. And actually, that's also for GraalVM, people who are embedding, using our embedding API, they're using JavaScript embedded inside of or R, Python, whatever it is. Yeah, it's much better, right? It's much better to look at that. Yeah.
So what are
actually? I like records. I was gonna say I like records. So 17. I mean, I know records didn't premiere in 17, but for doing microservices and shipping JSON around, I took an example application and I went between classes and records, and the code just shrank, right? Just shrank. It went down to like almost nothing. And the only negative part I would say is that the API did change, right? This is kind of a language evolution problem. Java Bean API has get, set, and records don't have get and set, right? So your client code changes, but it's way more concise for basically data objects, right?
Yeah.
DTOs.
And what's missing a bit is really deep support in JSON-B. I wrote some post about that, and it is working. What do you have to do? You have to put the JSON-B annotation on a constructor, or how to call it? Yeah, on a record constructor. So and then it's working, but it doesn't work out of the box. But if it's coming, it will be great, because then you could use Java records and just serialize them back and forth from JSON to JSON. And this is lacking right now. But you are right. Records are great. Text blocks are great, and what's happening with pattern matching, the start is also starting with Java 17. And the biggest impact in my world is the LTS, right? Because now it is it is now more interesting for larger companies, for enterprises.
Yeah, for sure. I mean, the goal there was to provide something usable in production, and no gap, right? So no gap between L2. You don't have to fall off into an unsupported situation. And a lot of, from a commercial perspective, most companies stick with one version, right? They, just like, right, you talk to customers, they work on a version, it goes to production, and it's just, they keep it, they care and feeding, right? Like, it's like it's there. No one goes and upgrades old systems that don't have any benefit to upgrade, right? They just do their job. So that makes sense, right? So 17 goes for a long time. We think a lot of people will stick with 17 for some time. Some will upgrade to 21. It works for both worlds, right? People who are upgrading have something stable. People who are sticking around have no hurry. They don't have to hurry and worry about, I must get off 17 because it's dying soon.
Yeah.
That kind of thing. Yeah.
Okay, so
it's a big change.
What are the big features of GraalVM? So since March to now, what's the update? So what was your first favorite feature? So do you have like top 10 favorites,
I was going to say 17. So 17 was one of my top features, which we talked about already, for those same reasons I mentioned, right? So if I'm writing microservices, and I'm working with Micronaut a lot these days.
One question regarding 17. So something like text blocks, is it something to do for GraalVM, or is just no, right?
No. The compiler is doing, I think, all the work, right? So
what is the hardest? So what's the problem with? Is it like Loom? Or where are you spending most of the time?
The JVM changes deep down are something to deal with, and also some of the code patterns. So as you say, there are some new code patterns with like the pattern matching and so on. All these kinds of language changes do affect us because, Java-C, it kind of translates your Java source code into bytecode. It doesn't compile per se, right?
Yeah.
So a lot of the work is pushed to the JIT compiler and our compiler. So we will have to deal with language changes.
And Java records? Was it a big deal or?
I don't think it was a big deal. In fact, the team kind of didn't get, I was excited by 17, and everyone wasn't as excited as me. They're like, oh yeah, we did 17, yeah.
Okay. Okay.
So apparently it's not this is my perspective. I'm sure that the engineers will tell you something completely different, but the view I got was that wasn't the issue because we spent a lot of time. So in terms of like what's big in GraalVM lately, right? The compiler team's working on optimizations, right? There's a lot of new optimizations like SIMD vectorization optimizations, things like doing some inlining before we do some other optimizations. So some things came from other teams, like the Spring team actually asked for this. If we do some inlining early, normally we don't inline right away, but inline a bit early, certain code paths become more efficient. So we can eliminate more code. Dead code. There's dead code elimination. There's a lot of loop unrolling. So a lot of the work, and again, users don't see it, right? Because it's inside the compiler. But taking loops and, there's different kinds of shapes of loop, for loops, while loops, if you can transform them, we've been transforming them into the same shape internally, and then we can apply a bunch of optimization. So there's a bunch of work has gone on that makes it easier for us to optimize code. And these are all documented in our release blogs. We talk about some of these things. But that's a big thing. But the biggest thing for GraalVM in this release, 21.3, is basically the performance of native image. So we've achieved a new sort of performance benchmark that we've been fighting a long time. So, JIT compilers have a lot of time to sit and gather metrics and optimize the code. So JIT compilers are going to outperform ahead of time compilation. They do today, they do now, most of the time. So our GraalVM Enterprise Edition compiler is about, over 20% or more, or 38 or something percent faster than, say, C2 in openJDK on a range of benchmarks. But native image has lagged behind. So native image has lagged C2 because we have to make all of our optimization decisions at build time. So we don't get the luxury of watching the code execute, which code paths are hot, what kind of shapes of data are flowing through the code, which will also help us optimize the code. We didn't have that. So with the latest release.
But what it means is that your native image is as fast as openJDK JIT compiler, right?
That's what we got to. Yeah. We got to the same level. So basically through a couple of features. One of them is profile guided optimization. So being able to run the app, gather some metrics, what a JIT compiler basically does, right? I mean, it's not as good as JIT, which runs forever optimizing, but if you run your workload and you turn on the PGO switch to gather metrics and recompile your native image with PGO, you will get better code.
Okay.
Which you then, of course, probably compile one, stick in a container, and deploy out there, right? And so you don't have to pay that optimization or that JIT compiler overhead at runtime. You've done it kind of in a smaller environment. And the other is G1. The G1 garbage collector makes the difference in terms of throughput.
Okay.
So just raw throughput, G1. So with G1 and PGO, I think the numbers I published were like 98% on average as fast as C2. So in some cases we're faster, some cases we're a bit slower, but we're basically in the same ballpark, which is huge because for us, the value proposition we see is take your Java application, which has all this, it's large, it has a lot of memory requirements, it boots slowly, slow is, relative. You compile ahead of time. It starts instantly. It doesn't have any warm-up, so it offers peak performance pretty much out from the beginning, and it runs about as fast as what you ran before. So really, there's no sort of performance penalty anymore for running with native image, which is a huge, for us, it's a big deal. Now, we still want to beat our own JIT compiler or meet our own JIT compiler performance, but that's where we are. So for us, that's a big deal because it's always been native image, it boots fast, lower memory footprint, good consistent throughput, like it's very reliable, predictable, but it does suffer a bit of a performance penalty. And so we've basically got rid of that.
In the last conversation with Thomas Wörtinger and on AirHacksFM, he mentioned that maybe in one time the native image is going to be even faster than JIT in some workloads, and in other workloads the JIT is going to be a little bit faster than the native image. So this was his.
It's like everything
Yeah,
it's like everything, right? There's no one perfect answer, right? There is no one. Workloads are always. It's always based on the workload. And that's the same thing we see with performance is depending on the workload, the kind of code patterns, the kind of APIs used in Java, you will get better or worse performance, right? So if people who optimize early ties the compiler's hands a bit, right? People who over-optimize. Yeah. If you write very nice high-level code using stream APIs, whatever, then the compiler can go to town and really take advantage.
Yeah. This is what I noticed. In the recent project, I use a lot of AWS lambdas, for instance, and there's a huge myth like Java is not suitable, and what happened is I just measured and found that even the cold start is not a problem because the cold start of stock Java, it starts 300 milliseconds, the cold start. And the subsequent calls are crazy fast. It's like 1 to 2 milliseconds.
Once you're up.
Yeah. But if you load, a lot of dependencies, this is where it becomes to be slow, because that's the problem. And also in all the serverless applications, you always have to make the distinction between synchronous and asynchronous functions. Because if the user has to wait, there's a huge difference between 300 milliseconds and 1 millisecond. But if the lambda is asynchronous, no one cares, because the first lambda is going to be 300 milliseconds and the subsequent calls will be faster, so you will pay less. So I play a lot, with JVM versus Graal, and this is not always clear to say, what is going to be cheaper. I mean, cost savings, because what you probably know is if you give the lambdas more RAM, you will also get more CPU. And
that's right.
Yeah, and if you start with 128 megs, you have less than one tenth of a CPU. I would say no reasonable app will run 1/10 of a virtual CPU. So if you would like to have one CPU, you can already you will have to dedicate 1.8 gigs of RAM, and with 1.8 gigs of RAM for one Java method, there's a plenty of RAM, so there is no need for optimization. So this is and I don't know whether it is clear to everyone how is it actually working, because I got strange questions. Should we learn Python right now? Is Java suitable for the cloud? It's like, what are you talking about? I mean, and if you compare Java with Python or Node.js, Java will always outperform the scripting languages.
Yeah, if you've got, actually, that's a good segue. So the performance numbers of the Truffle supported languages are getting better too. Yeah. So that's the mind-bending thing on GraalVM, right? The Truffle languages. So being able to take non-JVM native languages and compile to native machine code, right? So the Ruby numbers are really good. And one thing we have suffered from with these languages, ironically, I think because we're implemented in Java, we suffer from warm-up. So if you boot a Python program, right, it runs really fast right away. With us, we run fast at peak, but then we have a bit of a warm-up hit because it's written in Java. So we've been working on that. We published some papers, I think April. So maybe I told you last time. So now we said we talked in March. Okay.
In March.
So we published an article on this multi-tier compilation. So we're basically saying don't optimize at maximum initially on, say, Ruby or Python. Do reasonable compilation, and then for hot code, we'll improve the compilation, we'll improve the optimization. And what you find is we have a faster start, because we're not spending our time compiling, right? We're spending more time in the code. Faster startup time, and overall the performance curves are better. So it's really interesting. This is what compiler engineers do, right? They're like looking at how can we improve the overall curve from initial start, and you'll see these curves. It's a program's warm up. You see all these curves. They sort of go up, like it's the time it takes. It goes up, and they kind of level off as okay, we're running performant. So it's something we did. This multi-tier compilation. There's a really good blog on Medium, really well written. The key author was Alexander Prokopek. It's very comprehensible. So even for non-compiler engineers, I think it's pretty understandable what's going on. But it goes to show you what you can do. But so those languages have also improved quite a bit in the last year. Mm-hmm. And
what are the use cases? What are your clients or customers asking for? Because Ruby, for instance, is it still a thing? So is there lots of interest in Ruby?
There are a number of large companies who are Ruby shops. Right?
Oh, okay.
I wouldn't say the Ruby case is not a polyglot case. It's not like I want to embed some Ruby in my Java application. Mm-hmm. It's I want to run Ruby. So the biggest, one of the best well-known is Shopify. Mm-hmm. So Shopify is using Ruby. And Shopify is everywhere now. It's a Canadian company where I am. They're now like one of the highest market cap companies in Canada. It turns out Shopify. Mm-hmm. And I think the COVID pandemic has increased their use to. They use Ruby, and if you look on our forums, you'll see a lot of discussion back and forth with the Shopify engineers around optimizing Ruby performance. So we're really exceeding the performance of the MRI runtime with GraalVM, right? So they all care about performance, but other use cases besides the sort of pure play, like I'm just running Ruby, I'm just running whatever, is this embedded or scripting ability. Mm-hmm. Yeah. And so we see like NetSuite's a big example where NetSuite allows end users to write scripts. Mm-hmm. It's a very common SaaS pattern, right? Mm-hmm. Customers can extend the platform with some kind of script. Mm-hmm. And so we can use the Truffle languages to run those scripts, and we can sandbox them. Yeah. Right? So we keep increasing the ability to securely run those programs, limiting CPU, limiting time to run, limiting memory they can consume, APIs they're allowed to call. So I'd say that's a pretty big one. It comes up fairly regularly. People want to embed a scripting language in their Java app.
Mm-hmm. Almost runtime-less, right? So you can now you can write your Ruby code and just ship it somewhere, and it gets executed on GraalVM, right?
That's actually almost true. Yes, I know. It's too many strange use cases. But that was, practically speaking, the sort of scripting language for my Java app. That's what we do see that, right? And I think maybe that's what, I'm not too sure what the reason was for them writing Nashorn in the first place. Like, was putting JavaScript into the Java platform? I can't remember what the origins were, but I would assume it's
the origins.
Same,
I remember a little bit because at the beginning, Rhino was huge. There was the Rhino scripting engine, and it was used everywhere, even in JavaScript camp, because they use it for builds, and the Rhino was very slow. And I think, the idea of Nashorn is to improve the performance of Rhino. What I know, then the Nashorn was used more. And I used also Nashorn a lot for exactly these use cases you talked about right now. So to make, the, I would say, type-safe Java core a little bit more extensible without redeploying the app. So we could load, Nashorn scripts, and the great story was a Nashorn script could actually implement a Java interface. So what we did, we had a Java interface, like an algorithm, and we could load on demand, the Nashorn scripts. But then Node.js came, and, the entire JavaScript community moved on to Node.js. But there was a short period where, they were interested in Rhino. So I just, followed the blogs and saw that the Rhino was used a lot, and then Nashorn. And there was the JSR scripting API, the scripting API was huge in Java. and there was no JavaScript. There was, I think, Bean Shell and Jython and JSR2. It came with JDK 1.6, JSR2 33 or something, and this was so I got lots of requests by companies. So I had to explain what it is, and they ask about that. And I know there are lots of use cases where they start you remember Bean Shell, so Java source code in the database to make something scriptable and stuff like that. So I think the last one was actually it was not very popular, not as popular as GraalVM, but this was the main use case or the idea back then, I would say.
Yeah. I mean, I was in a different team at that time, still in the toppling team, and there was an initiative at Oracle to reach out to JavaScript developers. Right, it's a huge community. How can we improve our products to embrace the JavaScript community? And I'm not sure where the Navscorn fit in that story, but we were working on various kind of products where, making data easy to consume by JavaScript client programs, that kind of thing, right? Like producing, for us, it was producing JSON.
I still remember something. There was you remember Project Avatar?
It was Avatar was the code, yeah.
Yeah,
that's right.
The Project Avatar, I'm not sure whether it was Oracle or Sun, but the idea was that you could run server-side JavaScript. This was the Project Avatar, and there was the
that was Avatar. It was an overarching initiative. It was a whole bunch of things.
Okay.
And it became synonymous with what you're talking about, the sort of client server strategy. I don't know. It didn't really work.
No.
And I have to say, a good colleague of mine was saying it's never going to work.
Okay.
And they didn't listen to him.
Okay.
And now he's right. He's proven right.
Okay.
So.
Maybe this is John Klingen because he was the product manager of Avatar for a short period of time.
No, it wasn't John. But no, it was. Yeah, I was working with John at that time. That's right. Mm-hmm. Those were. It was interesting because in the top link world, it was pretty easy. We said, hey, what do customers want is data. Let's just give them data. Let's just figure out how to give out data so it can be incorporated into client-side apps, right? It seemed like an obvious thing, and we had a lot of metadata about the object structures, right? So we knew, and we had support for JSON and XML marshalling in Toppling. So we kind of put our pieces together and said, this is something practical we could do. It made a lot of sense, right? And today, people are still doing the same thing, right? How many Java apps do you see that read some database data and put data into a DTO and then ship it across the REST API? Yeah. I mean, we basically automated it. Right?
Yeah, and even on AWS, there's a DynamoDB high-level client. If you look at that, it looks exactly like JPA. So there's a Java with annotations, I would say. Yeah.
Yes.
So now back to GraalVM. So we covered already one feature, was Java 17. So the next one is your performance of the native image is similar to openJDK, JIT performance, I would say.
Yep.
Similar.
Basically, we have the features in place. Yeah. Mm-hmm.
And then there were two features covered, right?
That's two. Performance we do continue to work on performance, right? So it's a bit of an interesting game in terms of performance because you can improve the compiler performance, but at the same time, the JVM itself can actually improve. So JDK 17, the JVM has improved. Right? Over time, each release, we see the JVM itself is improving. So that means that openJDK's performance does increase or does improve, even independent of compiler technology. It's like the JVM is just better, right, at what it does. So you see that. I don't know if you saw this tweet. We were sharing it amongst ourselves recently. It was someone from the Apache Solar team. This is just like a day or so. He said he dropped in GraalVM and he got a 15% performance improvement in response time. Basically, he says for basically no effort. Right. This is the kind of thing that we go for. Right. So we continue to focus on that, but we have shifted a little bit in that we're thinking. Well, it's not a real shift. It's more of a what's our use case? So for compiler, we have the compiler team who focus on compiler optimization, but we are increasingly thinking about how do we make native image perform, right? So there's more of a focus on that native image use case for sure, because we're already doing quite well on the sort of JIT case. Then it's a question of, the code that comes out of the back end in native image is a little bit, it's a special case, right? It's not just like standard JIT code. It's going to be a bit different. So we're focusing a bit more on that. That's a big feature for us. Let me see. I'm looking at my other notes here.
And is there
build time?
Is there any thinking about the trade-offs? I don't know whether it's even possible. could we get a knob where we say, I have more memory, so improve, the performance or response time, or we can decrease the response time or increase the response time and by consuming less memory. So is this like a trade-off? Could we?
Well, yes. So G1, you can do a G1, right? The G1 in native image has exactly those options. So in fact, I was just talking to our performance engineer, Francois, about this, which is out of the box, G1 consumes more memory. And actually, I had this in the blog that I posted, actually, the enterprise blog on oracle.com or blogs.oracle.com/GraalVM, showing that we saw an increased throughput with native image, but then the memory consumption went up. So if you want to go faster, it was chewing up more memory. And it was because of G1. Now, the problem was it was default behavior. So G1 trades more memory, right, for throughput. But you can dial it down a bit. You can dial it down. You can say, okay, and then this is something we want to do. We did not post any numbers where we try to find the sweet spot in some sense, right? So if I increase throughput, if I decrease throughput a little bit, if I reduce the memory by from like maximum optimization or maximum usage to one less, what's my throughput look like? So you can tune, right? This is the nice thing with G1, or even there's cases where you've got certain kinds of applications where you shouldn't use G1, right? You should just use our more simpler collector, our parallel collector.
Are you talking now about the native image or about
native image?
Okay.
Native image, yeah. Yeah, so it really, said you do trade off memory for performance. And it's not in the compiled code, it's in like G1 tuning, for example, garbage collector tuning is one example. On the other hand, the other thing we're working on is, and Thomas has talked about this, maybe he mentioned it to you before, is having a range of optimizations on native image. Because today you kind of get, we spend a lot of time. People complain, right? The build takes a long time because we're spending a lot of time optimizing. But what if we optimize less? What if you got a slightly slower application because you're doing development work? You don't really care at this point for optimization. You can dial it down. So even within the sort of developer cycle, we're thinking that we could adjust the time spent optimizing to provide a better turnaround. So everything's a trade-off. It's memory, compute, time. These are your options, right?
Yeah.
For the runtime or the runtime.
Yeah, for command line interfaces or command line applications. So this is where I see, because in this completely different use case, I would use GraalVM now just for convenience because I get one binary, I drop it to my bin folder and go with it. So I don't care about memory or startup time that much. So if you would build faster, it would be great actually. So this is, I have such a use case actually, but this. I mean, I don't care because, all the tests happened before, and then I just believe it will work. So I have a final smoke test. If it starts and works, then I'm happy, usually.
Right. So we have some numbers, actually. I think they're also posted in our in the Medium blog, so graalvm.org, Medium/graalvm, on the 21.3 announcement blog. We have some numbers in there, and this is radio, or this is a podcast, so no visuals. So the table has image build time from 21.1 to 2 to 3. It went from 170 seconds to 163 seconds to 144 seconds. So we're seeing the build time for this little trait sample app decreasing, which is what? That's 30. It's actually almost 20% decrease in build time. The output image also shrank, so the smaller code size. So it went from 138 meg to 120 meg, our test case. This is actually Spring Pet Clinic, JDBC. That's what we're testing. So we're, it's a small matter of engineering, right, to improve the build time or reduce build time and to produce smaller images. It's just engineering work. We're just putting in the work to make it happen. The other thing we're doing is, this is actually another feature that I know that the native image team is very happy about, which is this conditional inclusion of code. So in terms of reflective config, it's now conditional. So you can say, if you see this class in the reachability, then include this other thing. And this came from the Spring team. They asked for this feature. Again, we're getting really good feedback from these downstream projects on like what would help them, what would help produce a better product or output. And this new change has helped the Spring team or Spring Native team reduce the size of their applications because they're not bringing in so much code. Mm-hmm. So if you don't bring in so many classes to look at, then you spend less time analyzing. It improves the throughput in terms of the build time. It improves the size of your output, right? The smaller native image.
So what's the problem with the Quarkus guys? Are they lazy or what? There is no feedback from them.
No, we got feedback from them. I think Spring. Well, we work with Micronaut. We work with Helidon, we're working with Quarkus, we're working with the Spring team. Did I say that right? There's four. Yeah. Four that I can think of. And we do get feedback. The Quarkus team have their own distro. They're using native image quite heavily. So Micronaut and Quarkus are both built native for this, right? They're designed to, right? Yeah. So they've already got sure. The Spring team has a longer path to go from Spring, which is has heavy use of reflection, right? Very heavy use of reflection, to a world in which it works smoothly. So the Spring Native project itself, like that whole initiative, is to basically bring Spring forward.
Yeah, you were right. The entire
Spring. So that's not fair. It's not fair to complain about.
The Spring is completely dynamic internally. They even, one point of time use Groovy for configuration. And Micronaut and Quarkus are extremely static, right? So they are different. Yeah.
They're designed from the ground up to avoid some of the things that would be problematic with native image, right? So that's why I'm enjoying Micronaut, because I know that, if I annotate some bean that needs inspection, they will basically generate the code to do that. So there's no reflection. It's actually, code gen behind the scenes. So I know it's going to compile fine with native image. And Quarkus is working kind of the same way. But Spring is trickier because, reflection. So they're doing a good job, right? So they're figuring out themselves. So I think the plan is Spring Native is kind of this incubator project where they figure it all out, and then they take their findings and they roll it into Spring Core, like the Spring Boot. I think that's happening next fall, Spring 6. Is that right?
I have no idea.
The numbers are not clear to me, but the Spring Native work is, and this is where we're getting things like, hey, if you inline earlier here, then we get a better result. So this is the kind of feedback. So they have a lot of code they have to test, right? That's good.
Yeah, but it's actually very good because most of the applications out there are reflection based. So you get a good feedback from Spring, because what Quarkus and Micronaut is doing is not, I would say, normal in Java, right? That you are upfront optimizing the entire code base to be loaded, generate bytecode in advance or code and load everything in one class loader. So it is such a highly optimization is not normal in enterprise, So this is like most of the application servers behave like Spring Boot. Yeah. So Spring Boot and application server are very, very similar technology, I would say.
Yeah, it's very similar. It's true, and it's kind of interesting. You and I always end up in these conversations like the language, but the use of reflection, it was there, and so everyone used it.
Yeah, exactly.
So, like Micronaut, the code looks just like Spring code in the sense of you annotate some objects with some annotations, like this is introspective, inject something here, and the implementation is just not using reflection. The implementation is using annotation processors to look at the code and go, oh, you need to introspect this object. I need to generate the helper code that will inject the right places to do the work. So they're just calculating at build time what you would basically calculate at runtime. That's all they've done. It moved the calculation, and in doing so, it's faster because reflection is slow. Reflection is also very memory intensive. It's very heavy.
Yeah.
So if you're creating handles to things, they're pretty fat.
Yeah, I mean the main difference between the past and now is that in the past the expectation was that you are able to reconfigure the server during runtime, and now we gave up. So we say, okay, we do it once, and then generate everything, and we can simplify the code base,
Yeah, it's true. The app server approach is enabled by this feature for sure.
Yeah.
Actually, that makes me think. So, have you been tracking the CDI, the non-reflective CDI work?
Yeah, the CDI Lite, you mean?
CDI Lite. Yeah. So same thing, right? I mean, it's like, hey, we can figure this out.
Yeah.
At build time.
And I mean, it will work. Why not?
Yeah, why not? It's just an implementation detail. I mean, if the spec, but unless the specification says this, you have to do this thing, and this thing's only possible to figure out at runtime. So what you need to do is make sure the spec doesn't do that, right?
By the way, funny fact or curious fact: at the beginning, before JDK 1.3, all application servers generated code. So what happened is during deployment, there was no dynamic proxy. So they read, the XML, generated Java code, compiled the code, and this was the deployment. And there was how is it called, Sun Server Reference Implementation, Java Web Server Development Kit or something like this. So you could deploy the Java, deploy Java code, and you could actually look at the source code. And WebLogic did the same. And then Java 1.3 came out with dynamic proxy. And the code was actually became slower. The deployment was faster, but the code was slower because reflection was involved, And everyone was excited about JDK 1.3, and I said, okay, it's cool, but it's slower. It's like, no, JDK 1.3 is great. We use dynamic proxy, and everyone was happy with dynamic proxies. And now with Quarkus, 20 years later, we do the same actually, right? So
it's back to the future.
Yeah, back to the future, exactly. Uh-huh.
It's the common case, right? Reflection was easy. It was a magic box. You could open it up and do all kinds of clever things, and everyone did it, right? I mean, you could do all kinds. And then you get into bytecode weaving, and you can do anything you want. Right?
Yeah.
So I mean, if it's there, people use it. I guess that's the lesson, right?
Yeah. Did we cover actually all the features, the main GraalVM features?
Oh, there's lots of features.
Your favorites, of course.
Well, my favorites was still the performance. I'm most excited about performance because I think, from market adoption perspective, if something's slow, it's always like, oh, it's worse, right? It's like it's better here, but it's worse here. Now I can say, no, it's basically across the board. It's basically the same or better. But I think that's the biggest thing. If you look through, there's all kinds of features. Some initial module support for native image. There's changes in. It's a ton of things, right? Random things. So in Truffle, they're working on. So Truffle was built as an AST-based parser, but languages like LLVM bitcode, Java are basically not. Well, Java is it's not an AST-based language. It's bytecodes. So we have a different implementation. So we're seeing within the Truffle world, what we're calling a static object model support. So languages that are more static, that have basically static typing. We are able to do new things, and we're working on performance improvements. So as you know, we have this Espresso implementation of Java that's built on top of Truffle. And so we're working on performance for Espresso. And so we saw some improvements in Espresso startup time, like around 40% improvement in the last few months of booting the application. So we're constantly working on these performance improvements to bring it up. So Espresso, when we released it, we told everyone it's functionally complete, like it does everything, but it's not fast. Okay. Right? Because of but we're sharing it now, and so what you're seeing is us basically bringing Espresso or Java on Truffle. Espresso is it's just a code name, right? Bringing that Java on Truffle implementation up to the point where it's competitive performance wise, and then you get to interesting use cases. So you could use Java as your scripting language in your Java program, and you could sandbox that code to make sure that it's run securely. In a box, right? So it changes the use case a little bit. You could do crazy things like script your application in Java 17, but the application is written in Java 11, right? So the language inside of the Espresso inside the box is a different version of Java than the actual host application. All kinds of crazy use cases become enabled, but we're working on that. So we really think that the Espresso platform can evolve to cover all the languages, and then we get that sort of. I kind of hate this term, but the universal virtual machine, right? It's one virtual machine that's running all these languages at speed and with interoperability.
But back to Java, what actually do with interesting use case for Oracle functions, right? Like a function as a service, because then you could just ship Java code without any runtime,
That's true. Now, but in this case, so I think the problem is you still have to load the bytecode and parse the bytecode and do all the things that you have to do with the JVM, right? So
but not me. I could just I would just copy the code over. I don't have to do the packaging. So right now with Lambda, I just stock Maven process. By the way, I had a chat with few developers regarding serverless and Java, and they say, okay, Java is not capable, and they opened, the AWS console and copied some Python and JavaScript, saying, look, Java cannot do this. So, okay, but this is terrible. I cannot just build, an application just by copying code, into the AWS console and hope it will work.
That's a demo.
So, yeah, this is a demo.
That's a demo.
Yeah, but they were so convinced that that Java is not capable because you cannot copy Java there. But we could with Espresso, for instance. This would be a use case for demo purposes, and packaging. No kidding, because right now I have to compile the Java and everything, but I still have to create a zip which is uploaded. It is a small zip, but still uploaded. But if we have, let's say, event-driven functions, then we don't need a lot of dependencies. So we can actually agree on a set of dependencies which are there. This was the available SDKs, and then would be Java like an orchestrator. So we could just load Java, and even you said CDI Lite, right? We could say, okay, CDI Lite is available. We could make a dependency injection available, a very simple one, and this would be a nice little runtime which would. And of course, behind the scenes, GraalVM during deployment will have to compile the Java code, of course, right? So,
yeah, you would have to. But I think that I struggled with this when I worked on functions. We struggled with this notion of what do you deploy? What's the deployment artifact, right? Is it like Heroku? Do you push source code to a repo, fires a build, deploys your code, right? So behind the scenes, there's containers, but you never see them. Then Docker, the rise of Docker, and suddenly everyone knew what containers were, and we said, okay, look, well. You want to deploy code, just deploy a container. We don't even care what's in the box. We don't care what's in the container. As long as it supports certain API, we don't care. So Java, Node, whatever. And then we're going back to but then people are finding Docker, that Docker functions experience, like you say, they want to copy a piece of code and just paste it in. So Lambda's popularized the non-artifact deployment, just a piece of code. But I don't know, the world just, so it's a pendulum. It goes back and forth between I want to control packaging myself, or I want you to do packaging for me. Where's the abstraction layer? What's the abstraction? Is it a container? Is it some source? Is it an API? It keeps changing, honestly. I mean, depends. It depends. But maybe Docker as a deployment artifact is fading a little bit because people are like, it's so common, right? We're all excited.
Yeah, this is like custom runtime. Docker is a special thing, and AWS you would ship just jar, or Node.js or Python, or custom runtime would be Docker, and on Oracle functions, I guess, is still FN Java, right?
They're still using Docker containers for deployment.
For FN Java, and is there any synergy with recent Espresso or GraalVM?
I think it's more native image. I really do think it's more native image. I actually had some recent work with the functions team talking about upgrading to a new version of GraalVM, right? And I really think that the static compile minimal container image is more the better use case. So they want lightweight, small containers. So if you have a cold node, like you say call function, somewhere there's a node that has to get that container image on it running. They got to pull that container image from somewhere. So you got to transmit the container image. You got to boot the thing up. It has to have as few layers as possible in your Docker container. All kinds of good practices for speed. So a scratch image with a fully self-contained, statically compiled application is probably optimal.
Yeah.
So that's where I think
it is optimal. It is absolutely optimal for the cloud provider, but the cloud economics on AWS right now are different. So if I'm from the user perspective, it's not always the case. If I would be the cloud provider like Oracle, I would just use native images. They are more sensible.
Yeah, I see your point though. It's true, and everyone kind of knows that on all these function platforms, serverless platforms, memory equals CPU, right? Because you can see this in all the platforms. Many people blogged about, hey, I've done these experiments. I can see it happening, right? It's because it's like Docker. You can get CPU shares, right? So you can say on Docker, for example, on a given host, give each container X%, or basically we can do some sort of it's just shares. So if you say 1 gig of RAM, you get so much CPU share. If you say 2 gig of RAM, you get a bigger share because there's only a physical machine behind the scenes somewhere that you're eating pieces of it, right? The trick is whether they oversubscribe. This is something that was interesting on Oracle functions. We never oversubscribe the hardware. So when you say, I want a gig, and you get some CPU share, you get that gig and that CPU share. Whereas other platforms, they may, this was like I think this was on. What am I thinking of? It's a while ago now. There was something on OpenShift where you could deploy, but they would oversubscribe. So you would get some fighting over resources, right? You could deploy lots, but you would find that your performance would degrade because if you had it really, it was you were having to fight over oversubscribed memory. So that's all interesting too. But you're right. If you really want throughput, you have to buy more RAM. So small functions or low memory requirement functions don't necessarily give you throughput you might be looking for.
And I would say they are really useless. I mean, this is 1/10 of a CPU. I mean, even
depends though. Depends what you do, right? Let's say if you're building a cloud service, for example, let's say like I'm Oracle, I'm building a cloud service that does something for you. They split into two pieces: data plane, control plane. And so in one side, all you're doing is configuring. So let's say I have to respond to an API call that says, please set my memory to 128 meg, or please set the memory for my function to 256 meg. That call doesn't have to run very fast. It doesn't have to run. It doesn't maybe run very often. I mean, it's not about throughput. It's just about I have to do some processing in a reasonable amount of time. I can build the whole service UI and everything out of these functions. It's fine. Now, if I'm going to go do a batch programming, different. Right? So it's not useless. It's just only useful for some cases.
What happened? There was one recently, a Java developer. I actually took two interesting cases. So I performed a code review, and in a Lambda, AWS Lambda, developers use parallel stream. And I was just curious because parallel stream, the parallelism depends on the amount of cores because it is based on the fork join, right? And I say, okay, how parallel is it actually? And what I did, I experiment. So I say, what happens if I deploy a Lambda, AWS Lambda, on 128 megs of RAM? What Java will see? Because you can ask, Java, give me the cores. Right. And what happened is you will see 2 cores. So this is the minimum. What you see are 2 cores on AWS Lambda. And then in one point of time, you see more. It means if you use parallel stream, the stream will get 2 threads, but you get 1/10 of a CPU actually. So, and I say, okay, maybe if you are deploying with 128 megabytes of RAM, it's not sensible to use parallel streams in this particular case, because there's not lots of parallelization going on of 1/10 of a CPU. And this is, you just have to know. And this is, the entire conversation, memory and CPU. And even if you just parse JSON, it's a huge impact. I mean, if the functions are getting JSON as input usually, and you are also emitting JSON as output. So you need a little things. And the last story, a developer used logging frameworks and just I think log4j and something. For no reason. It just wanted to have the dependencies, and the Lambda booted in 10 seconds. It's like, this is incredible. What are you doing here? It's like 10 megs of dependencies. And I say, I just included 3 dependencies, and then this, just because of 3 dependencies, all my performance went south. So I mean, you have a huge logging frameworks here included, right?
Yeah, we're seeing the same problem with native image compiles, right? So people add dependency, and it just explodes the space, right?
Yeah.
And we're becoming aware of frameworks that have bad, like if they have lots of dependencies, transitive, and it's a problem.
Yeah.
So this is a problem in general for not just as a compiler essentially, right? We are hitting this. People go, oh, native image is so slow. It's like, well, you have like 100 megabytes of stuff. You've included one thing, which included another thing, and then you've got this huge chain that we're having to look through, right? So it's a problem in Java for sure. And your developer, I'm sure this engineer you had working with, he's not the first person to add one little dependency, and then the whole thing goes so slow.
Yeah, he wanted to add Python. Says Java is not suitable for the clouds. So this was the discussion then, and it's okay. Just remove all your logging enterprise stuff. System out println is also good enough for just one method, and it just work. Micronaut, you are also somehow related to Micronaut, right? It's your team.
Yeah. So so Graham Roche came to work for Oracle. He works in Oracle Labs. He works. We both work for Eric Sedler, who runs Labs, and there he continues to work on Micronaut for general things, and he also is focusing on make sure we have good support for Oracle Cloud. That's another one of the things he does. So I've been using it because I'm finding it fairly straightforward to use. I like the simplicity. I like the tools, it's quite good. In fact, actually, the other day there was someone on another colleague had tweeted about, I had to write this little program and I wrote it in Python because it was so short. And he goes, sorry Java. And so then Todd Sharp, maybe Todd. So Todd's like, I will take that challenge. So actually, meanwhile, I was also doing the same thing. So behind the scenes, we're both writing the Java version. And with Micronaut, it was simple REST API. It managed some static structure, basically, right? With some REST APIs. And it was like a page. It was 30 lines of Java code, I think, altogether. It was basically the same size as the Python code, and I'm sure it runs way faster.
Yeah, sure.
So sometimes it's unfortunately the frameworks are sometimes where the advantage is, right? The frameworks did HTTP, handle all the stuff for me, did all the marshalling on marshalling, did all the automatic, checking that the parameters matched, the path of the URL matched the method, and so the binding. All these things happen, and it's in the frameworks. So it's not so much just Java. And I think the problem is that Python has some basic libraries or capabilities. People think that this is Python. It's not really Python.
Yeah.
If you're using frameworks, how good are your frameworks?
Yeah. And the entire discussion dies if you get, your first use case to implement, because you are stuck, with business thinking what the client would like to have. This is where and I would say Java is lean enough, and now a little bit, with the problems I hear is like Java is too slow for the clouds or too big, which doesn't matter because we covered this already, because the RAM and CPU are related in most clouds.
They are related. They definitely are, and this has changed the economics, right? So you now have to think about this.
Yeah,
you have to think about how much memory, how much CPU do I need.
And what you also have to think about is the costs. So I already delivered several talks, cost-driven development, yes. Because what back then the entire discussion about quality was a little bit esoteric, decoupling and whatever. But now the managers will see how expensive our architecture actually is. So we will have to justify all our thoughts regarding whether we really need 100 microservices or we can just ship 10, larger microservices. And this will be a huge, which I'm actually looking forward, because right now you could just argue, I don't know, my architecture is better because I'm modular, whatever it means. But now if modularity means more, you have to pay more money without business benefit. So now we are talking, right? So this is a different world.
Yeah. Throughput's part of it, right? So Twitter's Chris Tallinger has given talks about how they are. There's a couple of angles. He talks about power saving, so green technology. Mm-hmm. So if I can get my work done in a shorter amount of time, I can use less CPU time, right? So I can basically either use less, or I can squeeze more into the same, more work into the same physical compute infrastructure. And there's that, and then there's also the cost, like you say, right? Less compute is cheaper. So that's the thing they're using GraalVM for. They'll say, oh yeah, we use GraalVM. We get about 15% or something for these services. We're saving lots of money. He doesn't say how much. Mm-hmm. And he's left Twitter now, but these talks he gives. So there's real economic impact for performance. As you say, you do need to buy enough memory, enough compute to do your job. But how much is enough? You want it to be less, right? You want to be able to get away with less. So anything that makes your jobs work more efficient is saving money.
I would say the killer use case for GraalVM is actually for synchronous functions. And this is, you always will need GraalVM because the cold start is not acceptable. And the cold start is also because, as I said, this is half a second, and half a second for an end user is problematic. And what's also by the way, if you look at lambdas or functions, and stateless EGBs, they're exactly the same concepts. So meanwhile, I actually use my old slides to explain lambdas with EGBs, because the cold start, it doesn't happen once. It happens once per instance, right? So if you have lots of traffic coming in, so the first instance has a cold start, but it's busy. So what the runtime will do, create another instance with cold start. So you get a couple of cold starts at the beginning. What EGBs also had, there was the initial pool size. We just called provisioned concurrency. But now, this is the killer use case of GraalVM. Because what you can do with Micronaut, for instance, you can ship a Micronaut as an AWS Lambda. And it will receive HTTP events from the API gateway. We'll translate them to JAX-RS. So what will mean is actually you can lift and shift an old application server application written with JAX-RS and CDI, migrate it to Lambda, and create one Lambda with a couple of we are actually doing this with Pojos.
I was going to say, I'm expecting, like, where's the demo? You're working on it, right?
Demo, I already did it. There is a demo with Quarkus 1.5 years ago. And this is the official also in AWS. It's called, I think, serverless runtimes, where they even have a Jersey layer from AWS, where they are invoking Jersey through from HTTP event. So how this works, the HTTP event is JSON, and this adapter layer just reads the JSON and invokes JAX-RS resources. And you always need API gateway then. But this is where you have to use GraalVM, because then you get the cold start matters, and the processing time doesn't matter a lot, because in this layer there's no lots of CPU involved, right? This layer will just receive JSON, maybe call database, or usually what you will do is, create an event and send it to SQS, SNS, or Kinesis, or Kafka, or whatever. And this is where you have to use GraalVM. So this is the absolute killer use case. And what people don't know, that it's actually possible. And I showed them, the code is just like, it looks like microprofile. So it could be Micronaut, it could be Quarkus or Halidon. And this is your 15 years old code. We can now package it as a Lambda. But then we use GraalVM. We need GraalVM for that.
Yeah, I don't think I don't think that many people know about native image, but I think we'll see. I think in the next year, I think we'll see a bit of a change. I think now we're at I think we're at a bit of a turning point.
Native image. Everyone knows about native image. What people don't.
No, I don't think. If you see corporate developers, you're meeting people from clients. Are they aware of this technology?
Yes. Everyone knows about native image in my world. GraalVM is huge. What they don't know about is that GraalVM JIT compiler is so fast. This is absolutely not known. People don't even know. It is even other way around. For instance, if I mention GraalVM, they always thinking that we have to use the native image. So for them, GraalVM is the native image. So if someone mentions GraalVM is native image, and so they are not aware that GraalVM is a fast JVM, and they're also not aware of the polyglot. So if capabilities.
Mm-hmm. It's funny because in the past, that's the problem, right? So the GraalVM project is taking all this compiler technology and doing all kinds of different things. Mm-hmm. And a lot of people think of GraalVM as polyglot. That's what they think of at first. Like, oh, it's this polyglot. But as you say, really, it's powered by the core is this compiler, which is the JIT compiler, which we've also, repurposed because it's a compiler for native image. And even for Truffle, right? It's all compiler technology. Mm-hmm. But it's marketing issues, right? We have challenges.
I think marketing is great so far because these native images is huge, and I would say it is easier to sell than 20% better performance, because if I show the impact on startup time and the memory consumption is huge. So if you start Quarkus, let's say, it will consume, I think, 20 megs of RAM in what you see in JVisual VM. But if you look at from outside, it's roughly, I would say, 90 megs or something like this. Everything, the entire JVM. And the same app with GraalVM is roughly 10 megs or 11 megs or something like this. And the entire native image is around, I forgot, 20 megs to 60 megs, it depends, but it's the entire JVM and everything packaged, right? And if you show this is a huge impact. No one believes this. This is incredible.
I agree with you. I've come to the same conclusion. People don't like change, right? They don't like to change. So I can make your application go faster is really interesting. Developers aren't as concerned as maybe if you're in deployment or your operations. But if I can say I can take your application and compile it into this completely different thing in a completely different use case, that's much more interesting. Yeah. The average person. It's a completely different new idea versus a slightly better, rather than slightly better is completely new. And that's definitely more attention getting.
Mm-hmm. And back to Micronaut, I had already a chat with Graham about Micronaut and also played with that. And for me, it was at the beginning unusual to use or hard to use because I was not accustomed to, that many Maven configurations, like, the annotations processor. But what Graham said is that he already optimized that. So now it's a way easier than it was before. So there's, and because, this is interesting from marketing perspective. So what I really like is software which is simple to use. So this is why I really like application servers, because there was, I just downloaded them, started, and everything was available, right? And the Micronaut was optimized for, and Quarkus, by the way, as well. This was Quarkus at the beginning. I said, okay, I have no time to include, the 20 extensions each time. This is just stupid. So I know at the beginning that I will need everything from microprofile, but maybe because, health, metrics, JAX-RS, CDI, JSON-B, you always need them. This is not like there's one project which we can skip JSON-B. And if it is, then, how much will you save? So, and this impression was of Micronaut as well, but Graham said, okay, that he created like Maven profiles, which make it easier, which is appreciated. So I would say we don't have to optimize, until the last kilobyte. It would be, we can say, okay, there could be a semi-optimized version of Micronaut, which already ships, with parts of microprofiles, which you're already heading there. You have already JAX-RS, you have CDI Lite, and you have bin validation. So you have the 3 APIs, which are great.
Yeah, it's funny you mentioned Maven, because I always use Maven, and with working with Micronaut, they tend to default to Gradle builds, right? The examples include Gradle. So I started using Gradle more, and it's okay. It's not bad. It's a little bit less verbose. All that XML in Maven starts to look kind of ugly after you use a Gradle for a little bit. It's a little bit more concise.
But all my Maven projects were maybe 50 lines of XML, because if you have the dependencies like microprofile, you have 2 dependencies, plugins.
Right. Yeah.
So this was my world for 15 years, and Quarkus changed that, and Helidon is leaner actually as Quarkus. Because what Helidon does, they include, the entire API once. They have the entire microprofile at once. Mm-hmm. And in Quarkus, I have to add, small y metrics, small y health, and whatever. And I have to know that. But Helidon is more usable from the user perspective.
Yeah, it's a trade-off, though. So if you put things into your class path, it's a problem. I don't know whether it affects the compile. Like native, for me, I don't know whether it affects native image build or not. Probably not if you're not using anything. So
marketing. Are we building for developer, let's say, convenience or experience, or the best or the most optimized framework, right? So this is
right. Let the compiler do the optimization. Right.
Perfect. So when is the next release, significant release with Java 21? Do we have scheduled, our next podcast episode?
So the next release for us is 22. Which is the first 22 at 1, the first one in January. And we're actually working through that right now. We're having internal meetings of what features are we going to surface in 22. So I can't tell you the answer, but
of course.
You should check. We'll have to schedule a follow-up. I know there's some really interesting things, some fairly high-tech things baking that I'm eager to talk about, but I can't talk about them yet.
Yeah, perfect. And something on the WASM front? No.
It's coming along, so that's there. The work has moved. So it was built. Engineering team was building it. They've moved it into the JavaScript team because really it's part of the JavaScript story, right? So it's been moved under Christian Wirth, who leads the JavaScript work. So his team is taking care of it. The performance is. I saw some numbers. I think the performance has improved. There's lots of interest in WASM for sure. It's Well, as you know, we've added JavaScript to the Oracle database, right? So we embedded GraalVM in the database. And so one possibility there is, what about WASM? So if JavaScript's in database, would you have WASM support so you could then take native libraries and embed them in your stored procedure, right? This is a possibility. We haven't done that, but it's certainly a possibility in the future. So it's a going concern. It's
Oracle
dead,
functions.
And
Oracle functions.
And you could in Oracle functions. WASM, I mean, we had some. It's got some limitations. WASM today has some limits, right? So it can't do everything, right? But it has some utility. Well, we'll see when we announce this other stuff because we have some interesting uses for WASM.
Yeah. because
I'm going to tease you.
What your competitors are doing with Wasm, they are running already on the edges, with Wasm as a functions. So
but it's limited, right?
Yeah,
because there's no garbage collection. There's not a lot it can do. It can do some things, but it can't do everything.
I listened to an interview with someone, I can't remember, but they say the main feature of Wasm is that it is less capable than Java. So okay, this is interesting.
That's the main feature.
That's the main feature because it's not as complicated. So okay, interesting. Okay, perfect. So I will invite you back in January so you can talk more about then the high-tech features.
Could be too soon. We'll talk offline about a good date. I want to make sure that there's enough interesting stuff in the hopper.
Okay, perfect. Thank you.
Okay. It's great talking to you.